See.Know.Bias, helping students to see and know bias and create a future where we all see no bias. We are Team See.Know.Bias, comprised of 3 data scientists, Nicholas Broad, who worked on the modeling and MLOps and the user interface, Willie Costello, who had the concept, created the baseline model and the UI, and myself, Edward Johnson, who worked on the product, the story, and the testing. So what is media literacy today? Bias, polarizing, truths, untruths. Everybody has to make their own decision. And if we consider a story of President Trump on July the 4th weekend at Mount Rushmore, this iconic point, we can see 2 different descriptions of the same story. The New York Times talks about dark, diversive, and struggling efforts, new far-left fascism, whereas Fox News, on the other side of the spectrum, talks about legendary, ushering in, and full-throated condemnation of far-left fascism. So we've got a problem, and each of those descriptions, they show bias. So what's the problem that we're actually trying to solve here? Our goal is to develop media literacy in today's youth.
As Edward just said, the aim of See.Know.Bias is to develop media literacy specifically in today's youth, who, even though they are digital natives, have been shown to have great difficulty differentiating the real from the fake and the trustworthy from the untrustworthy online. This is a particularly urgent issue to address because the lack of such skills will only lead to further mistrust in news organizations, which will only hasten the spread of misinformation and disinformation online. The audience for our app is educators in schools who are looking to expand their media literacy curriculum and who could incorporate our app into their media literacy instruction. And what sets our app apart is that whereas other media literacy initiatives have focused on getting students to think about the sources and evidence behind information, See.Know.Bias aims to develop a new form of media literacy, the ability to detect bias in how a news article is worded, as in the example shown on the previous slide. Our app is built on a dataset of Wikipedia edits called the Wiki Neutrality Corpus. Wikipedia has as part of its policy that its articles be written from a neutral point of view and not include any biased or judgmental language. Because of this, tens of thousands of edits have been made to articles over the years to replace biased wording with neutral wording. Our app harnesses the power of these edits to create a dataset of sentence pairs before and after such neutral point of view edits. As such, we have a dataset of sentences with the same content, with the same meaning, but in biased and neutrally worded forms. Some examples of such sentence pairs are shown on this slide. Finally, it should be noted that identifying whether a sentence is biased and why is no easy task and is typically reserved for senior Wikipedia editors. Ordinary adults are, on average, able to detect such bias with an accuracy of only 54%. For our baseline model, we ran a count vectorizer, or bag of words model, on our corpus of text data, followed by a logistic regression model to classify whether a given sentence is biased or neutral. This model was able to achieve an accuracy of 68.5% on our test set, which is already a strong improvement on the human accuracy of 54%. After using bag of words as a baseline model, we tried a few other approaches, like TF-IDF, ensembling, and LSTMs. We achieved our best results, however, using BERT. Our pre-trained BERT model is able to achieve an accuracy of up to 74.5%. It does better than the other methods because it takes the context of words into account and uses subword tokenization, which makes it have virtually no out-of-vocabulary problems, unlike the other models. For proof of concept purposes, we prototyped using the smallest BERT model, though this could be scaled up to larger models for better performance. Surprisingly, our BERT model did not need much time to train. This may be because the original BERT model was trained on Wikipedia text data, and our dataset also comes from Wikipedia. In addition, we noted during training that the validation loss increased starting at the end of the first epoch, indicating that the model was overfitting, a problem we avoided by not training the model further. In terms of ML ops, our model is packaged in a Docker container and deployed on an Azure web app. With regards to UI, we use Streamlit to do a first draft and then switch to Plotly's Dash so that we could have more control over the design. Furthermore, we have an Azure pipeline hooked up to our GitHub repository that automatically builds a new Docker image each time the repo is updated, effectively serving as CI/CD. As a result of all this, what we've built is a copy and paste web app which is able to take in any piece of text, identify any bias sentences in that text, and highlight the most biased words in those sentences. Let us now see a short demo of how it works. Here we can see our simple user interface. The user simply copies and pastes an article into the text box, hits run, and then sees results immediately. The app comes preloaded with a few example articles, just to give the user a sense of how the app works. We will start with one of these. Here we can see all of the words that the app has identified as biased in this article. And if we want to know how confident the app is in its predictions, we can simply hover over the words to see their probability score. Different levels of confidence are presented in different colors. If we want the app to be stricter in the words it identifies as biased, we can raise its confidence threshold such that no predictions below that probability will be shown. Conversely, if we want the app to be more permissive, then we can lower the confidence threshold and more words will be displayed. By default, the app is set to identify only the most biased word in each biased sentence. If we wish to see the top 2 or top 3 most biased words in each biased sentence, we can do that too. But the real power of the app comes from its ability to take as input any article that the user copies into it. Here we have an article from today's Washington Post. And if we simply copy the full text of this article, paste it into the app's text box, we can immediately see all of the words that the app identifies as biased. And that, in a nutshell, is how See.Know.Bias works. In terms of future work, we have already achieved a number of the goals we set ourselves to move beyond our baseline model. Looking further into the future, we hope to build a batch API that would be able to analyze multiple documents for bias at once. We also hope to build a feature into our app to suggest neutral words to replace the biased words it identifies. Lastly, we'd like to build out the app to be like an in-app spell checker, able to identify biased words on the fly as text is being written. From everyone on the See.Know.Bias team, thanks for listening. We now encourage you to try out See.Know.Bias for yourself at see.knowbias.azurewebsites.net.